or something like that. There's no fixed limit here, but you know. Then you're gonna have an introduction. What I'm hoping to see in this introduction is a big picture statement. Why is this important? What's your problem? Sort of things. And then a literature review. Then at least 3 to 5 papers, which if you were smart, you already done it. Because I've been setting up the homeworks in a way that this would be done. So, you know, 3 to 5 papers. And you can wrap this up with your own objective. What you're doing. So if you think about here, you talk about the big picture, what's the problem, what you're doing, and then you talk about what other people have done. You know, I'm sure people have worked on that topic and you've seen it. And then what are you doing? What's your thing about? Does this make sense? Okay, how many of you have done this? It's ready. Okay, kind of. Okay, so almost half of the class already finished that. Okay. Next thing would be the methods. Here you would have a study area, which is where you're studying. And then you talk about the model you're using and the data you're using. And the modeling, we'll talk about what mesh if you're doing uncertain. So what's your mesh? What's your atmospheric stuff? What's your tides, you know, and all that stuff. So here you should, if it's an uncertain project, you're already defining, I'm using this mesh. And if you're changing meshes, how? So if you're making modifications, how and what? And then most likely you're going to have some kind of validation to demonstrate that this works. So you're going to validate this with historical storms, against NOAA data. It's a very logical thing to do. So there's no hard format here. This is just like a very general thing, just to give you guys an idea. And we've done all of this in class. And then the third thing you have here in your methods is metrics. If you're comparing something, it's how. Are you comparing water levels? Are you comparing inundation extents? And where and how you're doing that? Is it a percent difference? Is it a rate of increase or whatever it is? And then you're going to have results. You could present your validation as a result first, and then your actual results. One other thing I would like to see here sooner than later, and maybe we should talk about it next week, is your simulation plan. That might be in your paper, might not be. What do I mean by simulation plan? So it's literally a list of what you're running or what you're doing. And the number I'm looking for is an approximation of how much computational time you think your study is going to take. Very wise to have this before you do it, because then you have an idea of how much money from the bank you're going to spend. And it gives you an idea of where this thing is going. So are you having like 10 simulations, 20 simulations, 1 simulation, 3 simulations? And what you're using for each simulation? This will force you to think about your project in a very practical way. And it will force you to have an actual result at the end. Because if you run this with some kind of reality sense, you should get a presentable result of the project at the end. Does this make sense?
Yeah, what is it at the top of the last column?
SUs, it's the computational time.
Oh, okay.
It's billing units, system units. So here you just, compare and contrast, talk about what you found. Results, discussion. And conclusion. And references. Did I miss anything? Is that what you guys had in mind? Yeah?
Do we need like a list of figures and tables and that kind of stuff?
Not necessarily. I mean, that would be cool if you want to add. Sure. I like the idea. Why not?
I mean, I was just curious.
Now that you said
Some
it,
teachers
sure.
require- okay.
Yeah. Questions about this? Yes, go ahead.
Length just based on what you have to write about, or is there any expectations?
Of what?
Length of the paper?
No, there's no on time. It's whatever he needs. Don't do a 100-page thing.
Just say that.
Try to be as professional, as scientific as you can. So when you're preparing figures, try to prepare one nice figure rather than 10 print screens that are, this is not that undergrad GIS project anymore. So, be thoughtful about your figures and things like that. Try to
What
have
do you use to make figures? Like what software? Or
whatever you want. It's whatever you're presenting.
so for the presentation, or would you want to, I just want to know what is expected visually during the presentation.
So presentation, you have 15 minutes to tell the story. It's, as any professional conference. This is like, now we're transitioning to the real thing. So if you work for a company and you're presenting to, the American Geologic Association, whatever it is, and you go there and you're presenting that, that's what you would do. So your presentation will kind of follow this, but without too much text. And you're telling the story of this.
But I guess something like modeling, I don't know what the expectation in terms of like actually what you put up visually that people need to look at. Like, are we gonna have little do you want us to actually show little simulations in SMS somehow? Is there a way to do that, or do you really want to show like tables of like the data that we get? Like what? I mean,
Whatever you want.
okay,
Whatever you think it's appropriate.
okay. Or
If you put up a table with 70 lines, it's really hard to see it.
yeah.
So if you want to make pre-movies, that's great. If you want to do, there's no right or wrong. There's better and worse.
Yeah.
And it's really easy to tell if it was a bad presentation, and it's really easy to tell if it was a good presentation, but it's like, there's no expectation on do's and don'ts, like there's obvious don'ts, like don't put too much text, don't put huge tables, it just looks bad. So movies are good, but sometimes, it's all about how you present. It's kind of an art. That's why I want you guys to practice. I strongly encourage you guys to think about this and start on this now. Especially if we're going to push back a week for these presentations, because this will take time. And it's meant to take time. And that's why there's no exam, there's nothing like that. And that's why we can afford to have people of all different backgrounds in the same class. Here's where you do your thing. But, you know, there's a minimum that we're expecting everyone to. So I'll be really, really careful with that. Especially because simulations don't work the pace you want, you're making a mistake that you didn't realize, and Stampede will get busy at the end of the semester. There's people all over the country doing exactly what you guys are doing. So the time in the queue will increase every time. Would it help if I do a hypothetical example of this? So, like, or you guys, let's say Sharon wants to work with Hurricane Joaquin and the impact of potentially Hurricane Joaquin in the Hampton roads. So he will talk about it. Big picture here is very straightforward, and he would, you know, add his reference and things like that. What is his modeling approach? He needs to find a mesh that has Hampton roads in it, so he can do the modeling. He needs to validate that mesh with historical storms. So since he's working on Chesapeake Bay, he can use Hurricane Isabel, Irene, Sandy, Floyd, all the hurricanes that happen here. So he's going to go to the database, download those hurricanes, set up the simulations, go to the NOAA website, get the water levels, run those simulations, and compare the results. And that's his validation step. And then he can say, sure, my mesh works this well, it didn't work that well here, but that's fine if your mesh is not great. That's not the goal of the class at this point. You know, the goal is to show that you're aware of. It's fair here to say, my mesh, you know, I'm 40% off here. I have no idea why, but you know, hopefully not. But and then he was going to have a simulation plan to test that. For example, he wants to test what would be the impact if the advisories were to be true. So if you remember Hurricane Joaquin, as he was approaching the coast, NOAA was putting, the National Hurricane Center was putting out advisories. At some point, the track was right in DC. So he can use that track and simulate the storm using that track. And then he can use the track that was before that, the track that was after that, and he can simulate maybe 7 tracks, and he can, you know, get 7 different results as it was predicted. And then he can have as a metric a bunch of control stations around the DC region, or he was doing Hampton roads, so around Hampton roads. And then he can compare the water levels, and he can estimate what would have been the flooding there if Hurricane Joaquin were to have taken that track. So his metrics could have been coastal flooding, the area the flooded area in Hampton roads, or you know, actual water levels going up and down at some specific points. Maybe at the Navy base, they have a huge Navy base. That's that kind of thing. If he gets really ambitious, he can even add sea level rise. And then he can have a second scenario here in his result, which would be, what if there were 0.5 meter of sea level rise and that Hurricane Joaquin were to come 30 years from now? And then he can run that. So his simulation plan will reflect all of those simulations, the validation simulations, the Hurricane Joaquin simulations, and the sea level rise simulations. And he would, that's his thing. Does it make sense? Can you guys relate to what you're doing? Okay. All right. Okay. So we have 2 more classes, and then we get a week break. I highly encourage you guys to be wrapping this up during the week and asking Juan specifics about things, you know, why is this not running, or why this storm is not going, or, you know, you're a little bit more on your own. If you're going to play with meshes and you're not done by that week, forget it too late, you're not going to get it done. Here's the abort time. That week, if your project is not halfway through and it's moving, you should be worried, then you should change topic. I mean, it's time to think about it, because this will add time. It adds time to everything what I'm doing, because you guys are also busy, you work, you have other things. It's not like you do this full time. So that's why I would prefer to have everyone present before the finals, and have the finals for the people that are really lagging behind, and they have, you know, my plan was to have this done by the second presentation, but if not, you would have until the finals day to wrap this up. That was my plan. I'm okay with pushing the presentation there, but I think it's really, really risky. So be aware of all of that. And we can talk more about that. Okay? That was much more time than I wanted to spend.